Hello students, welcome once again in my video lecture. Dear students, myself is Ravindra Udvansar from Sri Tilok Jain Higher Secondary Vidyalaya Pathradi. Students, in the 12th chemistry, we have started the chapter Biomolecules. Into that, in last videos, we studied about the introductory part of biomolecules. Then we started with the carbohydrates. In carbohydrate, we studied the classification of carbohydrates. Then we studied the definition, classification and IUPAC nomenclature of carbohydrates. Then we studied about the glucose, that is preparation of glucose. Now we are going to study the next topic in this video, and that is structure and properties of glucose. Now here chemical properties of glucose are studied, which are evidences for the open chain structure of glucose. So these chemical reactions or chemical properties prove the open chain structure of glucose. So we shall go to the properties one by one. So first property, molecular formula. Molecular formula of glucose was determined with the help of elemental composition and with the help of its colligative properties. So this experimental study, it gave us the molecular formula of the glucose, and that was found to be C6H12O6. So this is the molecular formula of glucose, that is C6H12O6. Then second property, glucose, this substance glucose was heated for a longer time with the strong reducing agent, that is hydrogen iodide. So prolonged heating of glucose with hydrogen iodide gave the product N-hexane. So product obtained was N-hexane. Now what is N-hexane? It is CH3, CH2, 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 CH3. That means 6 carbon atoms in this alkane are in the straight chain. There is no branching. So this N-hexane was formed. It proves that all the 6 carbon atoms present in glucose molecule are arranged in the straight chain. That is, there is no branching of any carbon atom in the molecule of glucose or in the structure of glucose. Then third property, glucose, it was reacted with two compounds. First was hydroxylamine, NH2OH. The reaction of glucose with hydroxylamine gave the product known as oxime, having this type of group, CH double bond NOH. So oxime, this compound is oxime. Now oxime is formed only when there is carbonyl group present in the substrate molecule. So when any compound reacted with hydroxylamine, NH2OH, oxime is formed only when any carbonyl group is present in the molecule. So here oxime is formed, it is found that oxime is formed, therefore it is concluded that the glucose molecule contain at least one carbonyl group in its structure. Then glucose was also reacted with hydrogen cyanide, HCN. The product was found to be cyanohydrine. The group CHOH and CN, it is present in cyanohydrine. This type of compound is known as cyanohydrine. This reaction also proves the presence of one carbonyl group in glucose molecule. That means if a carbonyl compound is treated with HCN, hydrogen cyanide, then the addition reaction takes place here across carbonyl group and cyanohydrine product is formed. So it proves the presence of one carbonyl group in the glucose. Then fourth property, glucose was reacted with bromine water, which is a mild oxidizing agent, that means weak oxidizing agent. So with this mild oxidizing agent, the product formed was the gluconic acid, in which one COH group is there, that is carboxylic acid group is there or carboxyl group is there. So gluconic acid is formed. It proves that the carbonyl group present in glucose, which was detected in the previous reaction, is formyl group, that is aldehyde group, and not ketonic group. So if formyl group is present, then only this mild oxidizing agent bromine water can oxidize that group. If ketonic group is present, mild oxidizing agent cannot oxidize that group. Therefore, it is proved here that the formyl or aldehyde group is present, CHO group is present, this type of group might be present in glucose molecule, since the product formed is gluconic acid with the COH group. Okay. Then next reaction number 5, glucose was treated with acetic anhydride. Acetic anhydride, when reacted with a substrate having hydroxyl groups, it gives the product, that is ester product, known as acetate. Now what was found in this reaction when glucose was reacted with acetic anhydride? It was found that it reacts with 5 moles of acetic anhydride and gives the product known as glucose pentaacetate. So this type of ester group is formed here. So it gives glucose pentaacetate. That means 5 acetate groups, ester groups are formed in this molecule. This means the glucose molecule contains 5 hydroxyl groups. So it might contain 5 hydroxyl groups. Hydroxyl means OH group. So it might contain 5 hydroxyl groups. So this was proved in this reaction. Then next number 6, glucose contains 1 primary alcoholic group. This is proved with the help of the reaction that glucose was treated with strong oxidizing agent, that is nitric acid, HNO3, concentrated nitric acid. This strong oxidizing agent oxidizes the formyl group as well as primary alcoholic group. So here the product was found to be saccharic acid. The product was found to be saccharic acid. Saccharic acid is dicarboxylic acid having 2 COH group, carboxylic acid group at 2 terminals. So saccharic acid, it is the dicarboxylic acid of 6 carbon atoms. So this saccharic acid was formed from glucose. That means glucose contains 1 formyl group which was detected before, but it also contains 1 primary alcoholic group, that is CH2OH type of group, this type of group, CH2OH. Also here the gluconic acid which is formed previously with bromine water, it was also treated with the strong oxidizing agent, that is nitric acid, and here the product formed was found to be again saccharic acid. That means gluconic acid contains 1 COH group which is oxidized from the formyl group, but here saccharic acid is formed from gluconic acid. That means 1 more group is oxidized to COH group, and that group should be primary alcoholic group, and that is CH2OH. So whatever 5 hydroxyl group were proved previously, out of those 1 hydroxyl group should be primary hydroxyl group, that is this type of CH2OH group, it is proved. So all these reactions prove the different parts of the glucose in their open chain structure. So from all these chemical properties and evidences which are discussed above, the open chain structure of glucose was found to be like this. Here the carbonyl group is present, then that carbonyl group is formyl group. There is chain of 6 carbon atoms. So carbon number 1, 2, 3, 4, 5 and 6. Then carbonyl group was proved to be formyl group by reaction with mild oxidizing agent, that is bromine water. Then with the acetic anhydride, the 5 hydroxyl groups were proved, 3, 4 and 5. These 5 hydroxyl groups were proved, and with strong oxidizing agent, that is concentrated nitric acid, one hydroxyl group is primary hydroxyl group, that is CH2OH. This was also proved, and hence the structure of glucose, open chain structure of glucose is like this. It is proved with the help of above evidences, above chemical properties. Structure of gluconic acid is drawn in the Fischer projection formula. This is the structure of gluconic acid with COOH. CHO is converted into COOH. Other groups are similar. Then saccharic acid, COOH at carbon number 1 and COOH carbon number 6, which are oxidized. CHO group and CH2OH group are oxidized to COOH and COOH, that is carboxylic acid group. So it is dicarboxylic acid known as saccharic acid. So these are the structures in Fischer projection formulae of glucose, gluconic acid and saccharic acid. So students, we shall stop here. You see my further videos for further important topics. Thank you very much.